Okay, so today we are going to be working on indirect measurement, and you wanted to have answered question 1 and 2 as you came in today. We're going to go over it now, just to make sure everyone's wide awake, not looking at our phones or doing silly stuff, right? So, let's do this. Let's read this. It says, can you measure the height of a tree? Can you? Indirect measurement is any method that uses formulas, similar figures, or proportions to help measure an object that would be difficult to measure otherwise. Okay, some things are so tall we don't have enough rulers to measure them, right? Obviously, right? So there's ways to measure precisely without literally measuring it physically. For example, right? If you Googled how far is the sun from the Earth, you'd probably trust it, even though they didn't use a ruler to measure it, right? So there's indirect ways to measure, and this is one way using what we learned 2 days ago, similar triangles. So it says, look at the diagram below. We got question mark man. He's got a question, scratching his head. He wants to know the height of the tree, but cannot physically measure its height with a tape measure, okay? So there's a couple things in the picture. We have P, his height, and then we have M, his distance to a mirror, okay? So, the idea is that if you see something far away, you can take a mirror and put it on the ground, and then you can see the top of a tree or something, or a tower, and you can, with that information, create two similar triangles, and then you can theoretically make two fractions, cross multiply and divide, which is what we're going to do. Okay, so the distance from a person to a mirror would be M. The distance from that mirror to an object would be O, and then you have the missing H, the height of the object, right? So here's the question: what do you notice about the triangles formed in the diagram above? So are they the exact same or not? They are, like we just learned, they're called similar, right? So these are similar triangles. Similar means same exact shape, but a different size, okay? So, let's see here. The question was, what do you notice about the triangles formed? The triangles formed are similar. Which means, how might this help us find the tree's height? We can find the missing side using proportions. Okay, so okay, proportions. So we need to devise a plan to help question mark man find the height of the tree. What distances should be measured? What distances should he measure? Okay, so what three things do we need to know so we can figure out the height? First of all, he needs to know his own height to his eyeballs. Okay, so you probably know how tall you are, but that's not the same thing as to your eyes, right? So he needs to figure out height from toes to eyes. He also needs to know the distance to the mirror. And he also needs to know the distance from the mirror to the object, okay? If he can find those three distances, then he can figure out H using proportions, right? So to devise a plan, okay, we'll call him QM man. Should measure P, M, and O. And then, like we already said, he can find the tree's height using proportions, okay? So write that down real quick, that he should measure P, M, and O. Hold on, my board's acting crazy. There we go. Now, what would my proportions that I'm setting up be? So as usual, when we have similar figures, I like for you to connect corresponding sides. So you tell me, what does P correspond with on the other triangle? H. So P corresponds with H, and M corresponds with O. Okay? So P to H, M to O. So let's set those two fractions up so we can cross multiply and divide. Write this down. All right, well, if you need a pencil, ask someone near you. Get all your best friends with pencils. So nice. All right, so P over H equals M over O. This would be our equation we would use. Obviously, we're not going to solve this because there's no numbers, but that's the general way we're going to set it up. And it's obviously very similar to our similar triangles we talked about the last 2 days. So let's flip it over. As you finish writing this down, you can flip it over, and let's do some examples in the back, okay? Everyone with me? All right, so on the back, number 1, Jerry Jones is trying to measure the height of a nearby flagpole using a mirror as shown in the diagram. Okay? This is a rich man. All right? And he's looking down at a mirror to measure a flagpole. That's the way it is, you know. So, the mirror is 10 meters away from the flagpole. I want to label my picture. So, class, A, B, or C, which one should label 10 if it says it's from the mirror to the flagpole? Okay, so is everyone seeing that? Here's my mirror right here. Here's my flagpole over here. Between there is B, okay? So I've had other people tell me 10 is A or C, but again, B is from the mirror to the flagpole. Put a 10 right there. And then it says, and 3.5 meters away from Jerry. So again, the mirror is 3.5 from Jerry. Where am I going to put 3.5? Letter A, okay? All right, and then it says the height of his eyes is 2 meters from the ground. Where should I put 2? Okay, for C, from his eyes to his toes, that's 2 meters. And just like we talked about on the front, we should connect corresponding parts so we can set up 2 fractions, and then we can cross multiply and divide. So what does 2 correspond with? The missing length, x. 3.5 corresponds with 10. So let's set that up. 2 over x equals 3.5 over 10. Make sure you're consistent going left to right each time. So cross multiply, 2 times 10 is 20. 3.5 times x is 3.5x. After we cross multiply, then we're going to divide. $20 divided by 3.5 is 5.71. And my units are meters. 5.71 meters tall. Okay? So again, that's more than double this person. So he needed to use indirect measurement. Okay. Now, this next one, Jerry Jones visited San Antonio, and he noticed the Tower of America's shadow was 192 feet long, because he can notice those things somehow, right? And Mr. Jones himself is 6 feet tall to his eyeballs. Not really, but go with it. And his shadow is only 2 feet long, given the certain time of the day, the way the sun is. So, how tall is the Tower of America's? What should we do? Hey, we should draw a picture. That's a good idea. So I want everybody to draw a picture. So I need a man and his shadow, and I need a tower and its shadow. So draw those two and label it. I'm going to come around and see your beautiful drawings. Stick person is fine, but I want to see it. All right, we're looking at these pictures. Sure, we're doing shadows though, like shadow and shadow. I will attempt. Got that Jerry Jones in his little shadow. All right, and then we got that tower. Oops. Whatever. All right, and then all right. Jerry Jones and a tower. All right. So what should I label? So 192 goes where? Shadow of what? Tower. 192 on my tower's shadow. What else do I label? Okay, from his eyes to his toes, supposed to be 6 feet. And then what else? Shadow, it's 2 feet. Now, technically, a person or a thing and its shadow are going to be making right triangles that are similar. So, I'm looking for the missing height. What am I going to do? Just like last time, 6 corresponds with x, 2 corresponds with 192. So 6 over x equals 2 over 192. All right, let's cross multiply. 6 times 192. 1,152 equals 2x. And then we divide by 2. And what do we get? 576 what? Feet. Is that right? You think that's how tall the tower is? It is, all right? So you can Google it if you want. Now, the assignment is like this. You're going to set up proportions, cross multiply, and divide. Make sure you finish yesterday's assignment as well. The one from, I gave it to you 2 days ago. We worked on it yesterday. So I want to pass this out. I need both of those done and turned in as soon as you can. We do have a quiz tomorrow on similarity stuff.